the program over to Dr. Woodblack, who is going to come and talk with us about how to keep our LDAR programs current. Dr. Black?
All right. Well, thank you very much. Just so that you can see a current picture of me, but right now I'm currently an instructor at Northern Oklahoma College. And of course, I've spent quite a bit of time out in the industry, both oil and gas and refining, and I'm now the Process Technology Director for our Process Technology program. So what we're going to kind of do today is look at what the successful elements of an LDAR program are, also kind of talk about why is now a good time to take a step back and look at those program elements. Look at our problematic areas in LDAR so that as you go through the summer and you're working on your projects and you're looking at how to keep your program current, keeping things moving forward, summertime usually is that time when we do that. So we're going to look at those problematic areas and some things that you can look forward to in terms of leak detection and repair. So a couple of disclaimers and some focus items here. I'm going to stick primarily to the federal regulations and to some of the general trends that we're seeing across the industry as far as the consent decrees, enhanced leak detection and repair, depending on your permitting programs, those kinds of activities. But you got to make sure you're going to verify with your local regulations and your specific applicable federal regulations, because the SOCME rules are slightly different than the refining rules, and those are slightly different than some of the individual chemical-specific rules. So you'll want to be sure to look at those with your particular program in mind. We're going to look at some best practices, and some of those best practices that we discussed today may or may not fit your particular program or your particular situation. So definitely look at your program and how those might fit. Then we're going to look at areas within the LDAR that are ambiguous. You want to make sure that you look and work with your particular regulatory agency and your particular corporation and things to make sure that you're on the same page. I'll be using several acronyms today, so this is just kind of that acronym list. Some of the things that we'll be looking at are VOCs, which are volatile organic compounds. We'll look at some NSPSs, which are the New Source Performance Standards, and then the NESHAPs, which are the National Emission Standards for Hazardous Air Pollutants. And then we'll deal with AVOs, which of course are the audible, visual, and olfactory, or the good old sensory type leaks, so that you have that. So one of the first things we want to look at is, what is our purpose? Our purpose of leak detection and repair is to keep stuff in the pipes. And it is also a work practice rather than a specific standard. So if we were to look at our wastewater treatment and we were looking at our wastewater standards, there's an actual standard out there that says how much arsenic you can have discharged in your wastewater. So it's a measure and go type of a standard. Leak detection and repair is not like that. It is a work practice, which means, yes, we have some standards of performance we have to meet, but we also have to make sure we're following those work practices to ensure that we're in compliance with the regulation. And why we do it now is after the first quarter, hopefully most of your reporting is done. Yes, we know there's reporting that gets done in June, but hopefully you've got a chance to take a breather from that initial reporting situation that you had early in the year to where you can start looking at making improvements in your programs. Rather than just trying to maintain compliance, it's time to start looking about how are you going to meet and achieve those goals that you've set for yourself this year. So how do we do this work practice? And how do we reduce fugitive emissions? Well, there's a couple of ways that we do it. One is through throughput limits. So based on how our operations work, we're going to have a throughput limit which will hopefully minimize those fugitive emissions. The other is we put in certain specifications of equipment. So the types of equipment that we use, the types of valves we use, the types of pumps we use, a lot of those different pieces are going to give us our equipment specifications. And then finally, we're going to implement a work practice, such as our leak detection and repair, that's going to help us be able to keep those emissions in the pipe. So what are our current tools for leak detection and repair? Well, for most of us, that involves using a specific volatile organic carbon analyzer. We actually use that. Method 21 states those specific requirements of our analyzer. And for the most part, it's going to be flame detection, flame ionization detection, photoionization detection. But because of what we're looking at a material that's an organic carbon or a volatile organic carbon. We're looking at that material, and we're going to use a flame to burn it. So if our material that we're looking at to keep in the pipes doesn't burn, this analyzer is not going to work for you. And for some of our chemical manufacturers, that's an issue for us. If you're looking at some of our other compounds, our VOC analyzers may not actually detect everything that we want to look at. So our leak detection and repair is going to be pretty much hydrocarbon or volatile organic carbon specific. And that's something to keep in mind. The other part of it is that depending on your state, depending on your consent decree, you may have the alternative work practice that allows you to use the IR camera. But you've got to remember that the IR camera, because of how it detects our organic carbons, also may not necessarily detect everything that we need to look at. So it doesn't. From our leak detection and repair, we're going to be looking primarily at those VOCs. We're going to be looking at those things that the camera can see. And if we have something that falls outside of those two activities, we know we're going to have to do something else. And that could be bagging, that could be inventory maintenance. There could be several other ways that we're going to actually look at those potential leaks. But the big thing for our two analyzers that we typically use is it's only going to be as good as the calibration that was done for that instrument, and it will only be as good as the person who's actually going out and doing the work practice, actually going out and monitoring those individual valves, those individual components. And so we've got to look at our work practices to make sure that we're doing those. So we deal with our process equipment through equipment standards, as I've already mentioned. We deal with them through our work practice standard, and we're going to walk through this work practice standard, and then our equipment monitoring. If we find and detect a leak, we've got to do something about it. We have got to repair that leak, and we've got to make sure that that leak gets repaired in a timely fashion. So let's look at what the LDAR, the specific elements of an LDAR program. These are the required elements. They have to meet the applicable regulation. You have to have it so that it meets your regulation. We have to have a method for identifying equipment that's subject to our work practice. We have to have procedures for identifying our leaking equipment. We have to have procedures for repairing and keeping track of those pieces that are leaking. And we have to have a process for evaluating new and replacement equipment. So those are the elements that have to be there. Well, that doesn't necessarily, if I just had those elements, that doesn't necessarily mean my program is going to be successful. What we need to do to have a successful program is we have to be proactive. We have to really keep after this program day in, day out, and on and on. Because if you've got even a small facility, you've got hundreds of opportunities to not be in compliance. Each valve, each piece of equipment is a potential non-compliant situation. So there are lots of opportunities to mess up with leak detection and repair. Again, we're only as good as the person out in the field doing the work. And that's not just our technicians. That can be our operations and maintenance personnel. It can be your process engineers who are walking through. It can be your auditors. Anybody who's interacting with the equipment outside has the potential to be made aware of a potential leak, because we still have AVO leaks, those audio, visual, and olfactory leaks, that we have to watch for and document and maintain. We have to have documentation. We've got to have that documentation. We have to have a robust management of change program. We have to have a good database management system for our record keeping. And our database management systems are going to have to be electronic going forward because EPA is valves, compressors, our connectors, which include flanges and plugs and all of those little places where we can have a potential leak source, or any device or system that's regulated by your applicable subpart. So there can be pieces of equipment that are added or taken away by your applicable subpart. But let's go back to that open-ended line or valve. We know under leak detection and repair, we're not supposed to have an open-ended line, which means we need to have two sources that keep the liquid away from escaping to the outside. So we've done those as double blocks and bleeds. We've done those as a valve with a plug or a valve with a blinded flange. There's been a number of ways that we have actually terminated the end of that pipe. But when we terminate the end of that pipe so that we don't have a leak, it's not really an open end anymore. However, under the rules, we now have to go out and inspect those, quote, open ends. Because anytime if I have a flange or a plug or my valves didn't quite hold, my second valve didn't quite hold, and I'm actually seeing emissions at that termination, that's now considered an open-ended line. And so now we have to go back and we have to do those monitoring. So we're seeing a lot more enhanced LDAR programs that are having to include all those potential termination points as an open-ended line inspection. So you might want to look at how that's being handled at your facility. So common materials that you want to have to support your program. You want to have all your applicability determinations. Is this particular component in or out? If I'm doing skip monitoring, have I got all the appropriate records to document that applicability? I've got to look at my stream compositions. If I'm using the batch process exemption for keeping something under a certain number of hours, I need to have that applicability determination. It's nice to have your piping and instrumentation diagrams that are marked up so that you know which lines are subject to leak detection and repair and which ones aren't. Which ones have those hour determinations on them. And then you want to maintain your database. And now, given as much information as our databases can handle, the more information you have in your database, the better off you are, because it helps you do a lot more inspections. You can do a lot more treatment of your data. You can do a lot more data forensics by having more information in. That gives you another problem is, how do I make sure that that information is current? So you do have, it's a double-edged sword in that case, and you want to make sure you're keeping track of that. So other identifiers, field tagging is great. While it's not required by the federal rules, it is a routine practice, and it helps you determine what's in and what's out. And it also helps you track, did I actually monitor that component? So that field tagging does become important. If you've got isometrics, some of those isometric drawings can be very helpful. Any kind of other sensors, now we're seeing a lot more sensors in terms of pressure release devices. There are other sensors that you can use to determine whether or not you've had a leak. Vent socks are good. Other kinds of flags are good, pop-ups, depending on your material. So we've got those things that are out there. Our component identification, you want to make sure you've got it correct. So you want to describe your component, either using your physical tags and your methodology when we're out in the field. One of the things, if you look at different layers up a tower, if your tagging is inconsistent from one layer to the next layer, it makes it a lot harder to verify, do I really have everything in there? We also need to make sure if we're doing tags, how does your facility deal with a tag that all of a sudden somebody's walking down the road and we see a tag on the ground? Where did it come from? You want to be consistent in your databases. How do you identify locations? And you want to be consistent. The more consistent you are, the better off you're going to be able to do to go in and routinely check your program and looking at it. And you want to make sure you've got those descriptions in the database. You want to keep there are records that are intended by and are specified by your regulation, and so you want to make sure you have each of those records if it's required. And then you may want to have some additional records. EPA is definitely moving to the electronic copies, and you want to make sure that you have those records accessible for the required number of years as by your permit, your consent decree, and the specific regulation. So you want to make sure you're keeping those records. Your reporting is going to be determined by the regulation, and it can be determined by your permit. It can be determined by what you're supposed to maintain. So all of those pieces need to be accounted for. Your format is now moving towards electronic format, so you're going to have to kind of watch how that's being done on your various agencies that are getting this data. Your frequency, some frequency of the regulations reported are there, some others don't. Most are semi-annual submittals, so you need to make sure some are quarterly and some are annual. So you want to make sure you're getting that information to the right place. And then there's the issue of who needs to see it and what report needs to have it. When we go out and audit and have looked at those auditing, we've actually found that because it makes it easier for the person that's doing the report, you end up sending a lot more information in than you have to. And so you might want to look at how you're doing those various reports. So now let's look at our other program documentation and some of the problematic areas where we're going to get into. If you have a good, if you've got a good program manual or a series of standard operating procedures, some things you might want to include in that manual. If you want to make sure you should have what are my affected process units and my affected equipment. And look at your definition of process unit, because your applicable subpart and the definitions at various state levels, what is a process unit changes, and how you do those calculations change. So if I'm looking at my DTM, my difficult to monitor, or my unsafe to monitor percentages, and I need to look at it by process unit, how we typically break it up from a monitoring perspective may not jive with how it needs to be looked at as a process unit for those regulatory aspects. You want to have your standard operating procedures. You want to look at your monitoring schedules. You want to look at your monitoring plans, particularly if I have difficult to monitor or if I have unsafe to monitor components. And you also, a lot of those plans say something to the effect of, I will monitor my unsafe to monitor components when it is safe to do so. Well, what does that mean? What is when it's safe to do so? Usually it's prior to a turnaround where you're getting scaffolding built, and so now you have the scaffolding up there. And then it becomes a question of how do I track when my scaffolding comes up so that component is safe to monitor and I can go out and do it. So those are some of those little nuances that people are starting to look at over and over again about, well, is it safe to monitor? And how do you, as the LDAR coordinator, know that if you're inside the office and then all of a sudden you walk out and there's a whole bunch of new scaffolding that's been put out in your plant? You want to keep your training documentation, what kind of training is there, and whatever your policies and procedures are. So what are our problematic elements and where do we look for things that are going to be affected? Well, first of all, anytime there's a change of a transfer of responsibility, that's going to be a problematic area. If I'm doing management of change, even though I, as the LDAR coordinator, might get that P&ID to review for that particular change out in the plant, when that change actually occurs or when that change actually was implemented might not necessarily get to me. So that may mean I may have a missed monitoring event because I didn't know when that pump came into service. So I want to watch those potential changes or transfers of responsibility. My definition of the process unit, I already kind of went into this a little bit. The process unit definitions are changing, and as they go through and do residual risk, as they go through and do updates at the NSPS, you may actually get a new definition of the process unit. And with the implementation of the uniform standards, some of that equipment may be changed as well. So you want to really watch what that definition is. Our applicable equipment, we want to make sure that we have accounted for everything there. Usually where our problems occur is in MOCs, when I have components that disappear, components that appear, and when they actually go into service. That is really part of the harder part of what we're having to deal with right now, is how do we track when a component goes into service. We have our sensory leak programs, and how do you track that? If your operator is going out and is doing his or her daily line checks and they actually see a potential leak, are they documenting it? If they actually put a pipe or a wrench on the pipe to actually shut off the leak, are those getting reported and captured? Are somebody getting the operator notes and the transfer notes to be able to see whether or not something has to go out and be checked and verified that there is no leak anymore? That's another potential issue that you have. Open-ended lines, all of us have issues with open-ended lines. Some of them are very easy to detect, some of them are not so easy to detect. They do require a sustained effort. They can be open-ended line issues, can be a process unit by process unit problem. You can go into one half of the plant and not have an open-ended line at all, and you can go into the other half of the plant and see open-ended lines everywhere. So how you handle open-ended lines is definitely something that you want to look at and deal with. And again, it could be crew-based. Which shift is on today is going to have more open-ended lines than another shift. So you want to watch those kinds of things. We are seeing, as I had indicated, we're seeing that open-ended line inspection programs are being implemented for various enhanced LDAR. So you're looking at those pieces. You want to make sure that those caps and flanges may have to be being monitored depending on your specific program. And then any valve except for a safety relief valve having one side of the seat in contact with the process and one side open to the atmosphere is considered an open end. So plugs and open ends have to have that second valve. You've got to have that double block there. Then you get to the program responsibilities with the monitoring and the monitoring data. Of course, our person who's out there monitoring needs to be safe. They need to be doing proper method 21. A lot of the violations that we're seeing is that instruments aren't being calibrated appropriately, and that you need to make sure that that's happening. The monitoring instruments, how they're being troubleshooted, our flow rates, how those pieces of equipment are being maintained, all of that needs to be there for your method 21. How a person monitors needs to be looked at. Are we getting all of the potential leak points when we go out and assess that particular component? We want to look at those pieces. And is the technician getting a chance to look at each and every component that they need to as they go through monitoring? So even how you set up your monitoring routes can lead to potential missed monitoring events depending upon how that's being done. You want to make sure you're keeping your notification, and you want to make sure you're doing your paper tagging, your leak tagging appropriately and consistently. Because what we do find when we go out in inspections is you'll find that there'll be a leaker tag that's missing. The leaker tag didn't stay on the required time period, or the leaker tag has stayed on way too long. So there's some things that you want to look at on those pieces for those paper documentations for your leakers. The response time of the instrument, this is another area where things are a little difficult, and you're seeing more and more inference on them, is making sure your instrument is has the appropriate response time. And then are you doing all your follow-up monitoring and repair? And that's a place that you can actually go into the database and do some database forensics to be able to look at where we're at. So it's kind of important that people understand some key definitions associated with Method 21. we have several different time periods that we deal with. We deal with the time periods from scheduling and looking at our leaks, but when we're actually doing Method 21, we do a survey to see if I'm seeing a leak. So that's the first piece of time that you'll have when you're doing your Method 21 is that survey. Did I see a deflection that's going to cause me to have to stop and look at this component and look at this particular spot in this component a little longer? Then I have to make sure I'm staying the appropriate dwell time. And that dwell time is the time spent on that potential leak point. And Method 21 says that that's 2 times the response time of your instrument. So if most of us have a kind of a rule of thumb as to how long that is, but let's say your instrument's not working quite so well today. Are you really staying on that point 2 times the response time of your instrument? And that's one place you want to look at. Then you want to look at our calibration drift. How is that drifting across? And the third time element that you want to keep in mind and consider is travel time between component to component. And when I'm doing database forensics, I want to look at my survey time, my dwell time, and my travel time. Is that reasonable for the monitoring route that's being run? And we'll kind of talk about that here in just a second. So I want to look at my proper leak definition. I want to make sure I'm doing a proper survey and a proper dwell. I want to make sure I'm doing a proper survey in where the probe is by component type. I'm looking at that travel time between components. And so when I start to do my database forensics, which I can go in at the end of the day and I can look at and pull somebody's route, and I put it and I actually populate it by timestamp. So you sort it by timestamp, not necessarily by component number. You want to sort it by timestamp. You want to look for any abnormal data pattern. You want to look for the fact that my person monitored at tank 151 at 9:55 and 34 seconds, and then was over 3 tanks down at 2 minutes later. You're going to raise a red flag saying that doesn't seem reasonable. That doesn't seem reasonable. But if I'm sitting at a manifold that I have 50 components right there, and my person doesn't even have to shift his weight in order to monitor another component, then I'm looking at primarily survey time and dwell time for those components to make sure that that's reasonable. So those are all kinds of things that you can do. You can also download that data, populate it into Excel, and actually plot it by time and start looking at abnormal data patterns in leak rates. One time I looked at it, and I always tell this story. I had a person that I would go out, and he always had all his leaks first thing in the morning. That's all he had was first thing in the morning. He had all his leaks, and then in the afternoon, he almost never had any leaks. And so you're kind of going, well, what's the deal? And why is it always in the morning? It turns out that particular individual was going out and doing all the daily rechecks. And he ended up most of the rest of the day where he didn't have those leaks was when he was in a very nice, clean unit that typically had a very, very low leak rate. And so that does make sense once you actually went and looked at it. But you had a flag to go out and look at those particular data patterns. The required monitoring information has to include the name of the person conducting the monitoring, the instrument used for the monitoring event so that you can go back and check that response time. You can go back and check that maintenance on that unit, the instrument calibration data, including the calibration gases used, the instrument response time, the date and time of the monitoring event, your background readings, and your component readings. And one thing that we are seeing out in the field is a lot of times the people are not taking enough background readings to compare with. They'll take a background reading at the start of their monitoring run, and then they'll take a background reading at the end of their monitoring run, and not necessarily take a background reading during it or at a specified frequency. So you really want to make sure that you've got those background readings to make sure that you have things that are out there. So here's some rule of thumbs. And, of course, these thumbs are depending on your particular facility and depending on your hours of the day and all of those. Look I flag, when I do database forensics, I flag anybody who's doing more than 350 components in a day. Then I file, and then I say, okay, so I'll pull those days that have greater than 350 components by a single individual. And then I go back and look at, well, how many hours did that person work? Is that reasonable for the number of hours that they work? Maximum components in a minute. I look at any minutes that have greater than 5 components in it for sure. To go back and look at it. But then you're sitting there going, even depending on the response time of my instrument, that may be even too many. So I want to look at how those are over there. I look for maximum components in an hour, 60 components in an hour. And again, depending on which part of the facility I'm in, I'm going to be very, very much looking at how that 60 components rates. If I'm in the tank farm, I might actually lower that to 30 components in an hour to make sure that those times are reasonable. So I want to know where those are. I also have to look at, when I'm doing my components that are 5 in a minute, I'm going to hope they're all very small components. I'm going to hope that I don't have a 6-inch valve in that 5 to 6 minute period, or that 5 in that 1 minute period. So I want to look at the size of the components. Again, is it reasonable? I want to look at the location of those components. If I have elevations, I'll even look at those elevations of those components, making sure that that makes sense. Then I do routing, and is the routing efficient? If my routing is efficient, that also helps me make sure that my inventory is correct. So there's some good things that you can look at there. Focusing on repairs, missing the repair deadlines for first and final repair attempts, as well as missing those remonitoring events. Did I remonitor appropriately? Did that component come back into the monitoring sequence after it's been leaking appropriately? So if I've had a leaker and I was on a quarterly skip monitor, I may have to monitor that component monthly until it gets back on its quarterly system. And if, depending on where you are in your month, sometimes that gets lost. And we want to make sure that those rules are following appropriately. Not performing enough post-repair monitoring, and again, some of them are dependent on the leak rate, so you want to make sure that we're out there. And then improper application of delay of repair. Can I really do a delay of repair on that component? Can I really do a delay of repair for a certain thing? That's particularly on pumps. You really want to look at those delay of repairs on pumps, because you see a lot of improper aspects of that delay of repair there. Management of change, you've got to watch that, and usually the place now is getting that first initial monitoring event. When did the component come into service? And now there's a lot of things that pumps and valves need to be monitored to ensure proper installation. So that's another aspect of the rule where things might get fuzzy. So we're getting close to the end here. So you want to be aware of your change management, because that's going to be what's going on. You want to make sure you're reviewing your information in your LDAR database to make sure that that's happening and you're getting that change management as well. You'd like to identify the rules so that you can make sure that and you want to distinguish between a voluntary rule, a proactive practice at your facility versus what's required by the regulation. So you really want to kind of watch that. You've got to keep your databases up current and accurate, and that's where we get back to the document. It's a work practice, so I've got to have something that was an evidence to say that this occurred and it's happening, and that way we're catching it. So each component, each document is an opportunity to be in a non-compliant situation. So your program is only as good as your documentation. So that fundamentally, that's one of the places you've got to worry about. Your QA/QC, we've kind of talked about it. So this just kind of summarizes where we are on our QA/QC. You want to look at your monitoring identification, your frequency, your data, look at your reports. Those are places for your periodic reviews. You want to look at your instrumentation records, look at your monitoring data. You want to look at your typical frequencies. You want to look, is that truly a difficult to monitor component? Is that truly an unsafe to monitor component? And do you meet your percentages if you have a percentage requirement? So you want to watch that. You want to look at how my best practices are for my folks that are out there monitoring. You want to look at your added and deleted components. That's a good place to do database forensics. Go in and look at how many components were added over the last week, and look at, or how many components were added over the last 6 months. So those numbers make sense. We want to look at our MOCs and have a way to go back and look at that MOC. Does the number of components added or deleted match the type of work that was done in the MOC? That's another place to look. We want to have our best practices. Shadow monitoring is a good practice, walking the lines, looking at tags, and then your database forensics. And database forensics can tell you a lot. You want to check your repairs and timing. You want to look at your delay of repairs. And you want to verify that the requirements that you're following are per your individual rules periodically. You might even want to put a checklist. When was the last time you went out and looked at your rule is kind of another way to look at it. So we want to kind of keep track of that. So here are some program best practices. You want to make sure people are trained on the LDAR program. A couple of best practices I've seen is that they actually ran slides on leak detection and repair in the break rooms, so that they had those up there, and they had competitions between process units. So there's some other things to look at. You want to make sure your existing maintenance work order systems, your existing systems whenever possible. When you have multiple systems, you have a place for multiple points of error. So if you can utilize the same system, the better off you are, because everybody's familiar with those systems, and you don't have those transfers of responsibility. You want to use both personal and electronic communications to keep people notified of leaking equipment. We want to make sure that the first attempt at repairs are done as soon as possible so that you're not missing an opportunity to get there. And now we get those lovely leakless and low-leak technologies that are available. And you want to document those, and you want to keep track of how that's being done so that you can kind of help your program out with those pieces. And you may need to keep extra documentation as part of your maintenance records. We have some facilities that are out there, they're required to put in leakless technology, and you wanted to make sure that the warehouse no longer had the old kind of valve, so the guy who went out and repaired didn't put in the wrong valve down the road. So those are some things to look at. And you want to communicate with your maintenance group to ensure that repairs are done promptly and everything's re-monitored and where you're out there. Self-audits, there's nothing that gets around self-audits. You really need to do them. You need to do field walkthroughs, looking for open-ended lines, looking at your component inventory. You need to look at your calibration gas documentation, look at your calibration records, look at new equipment. And when you're walking around in the plant, you might want to look for, does something look brand spanking pretty shiny new, and has it been accounted for? Schedules, those help in knowing what schedules and which places are out there, and if you've got some links back and forth from your database forensics to say, ooh, I probably need to go out there when this shift is on, because that'll help do the education portion of the program. And then look for your out-of-service components and when those service things change. So some final thoughts. LDAR is supposed to be a work practice that's supposed to be relied on with common sense. And we all know that common sense is not common. And it is truly something that's out there. When you go out there and look and you walk out into the plant and you go and you see a visual leak and you go, well, how come nobody reported it? And then look at it and say, well, it's not time for the LDAR guy to come through. Well, it's still a visual leak, and I saw it, you saw it, so how come it hasn't been taken care of? And those are things that you have to deal with it. Our LDAR programs have thousands of ways to go wrong. And if you think of how many monitoring events over the course of the year, how many pieces of equipment you have, how many paper trails that you have to maintain, there's just a whole host of spots that it can be there. And nothing is going to be all-encompassing. There is no silver bullet to your LDAR program. you just have to be on top of it every day because it's going to be one of those things that you have to deal with. So I'm going to flip it to the next one. Here are some things on common sense so that you can actually see where those things are out there. And I like the W.C. Fields quote, horse sense is the thing that the horse has which keeps him from betting on people. So you really have to watch it and keep going. So I'm going to open it up for questions. Does anybody have a question? You can either chat it in and we'll go from there, or otherwise I'll turn it back to Rodney.
Well, Dr. Black, I'll just say that we've had a couple questions that were typed in. People were asking if the slides were going to be available, and this webinar has been recorded, and so a copy of the recording and the slides will be available on the ISA LDAR Symposium website. Are there any other questions for Dr. Black? I believe we've unmuted everyone, so everyone should be able to ask questions, and you can also type questions into the chat. If not, I think that we've come to the close of the webinar, and I do want to thank Dr. Black. We've certainly been able to gain from this particular webinar ways to verify inventory, facts about Method 21, and just general common practices on safe LDAR compliance. So I appreciate this. And I see Richard says it's good to hear from you again, Frankie, so that's really good. Dr. Black, you have a couple of fans out here.
Well, thanks, folks. I appreciate everyone's attentiveness and joining us this morning on the webinar. And I appreciate Rodney and the folks at ISA for letting me do this.
Absolutely. We want to say to all of the attendees, if you haven't already, please register for the ISA LDAR Symposium. It's our 15th year. We're going to be in New Orleans, Louisiana, and you'll have an opportunity to hear presentations just like this and others that will help you maximize your learning experience in LDAR. And again, we've got the EPA that's going to be there, a regular cast of characters of presenters. We've got some entertainment this year, a lot of new things happening. So please plan to attend. We've got our exhibitors where you can see products and services, and then we're going to have a very nice reception that's going to be hosted by Avanti Environmental and a number of other sponsors who are going to be there. We appreciate all of their participation. Dr. Black, I want to thank you again for sharing this valuable technical content with us. I'll say one more time that the slides will be available on the ISA LDAR Symposium website. You can go out there and get a PDF of the slides and also listen to the presentation recording again. Thank you, everyone, for participating today.
Thanks.
Thanks. Thank you.
Have a great day.
Thank you. Yep. Thank you. Thank you.
Frankie, are you still on?
Yes, I am.
Right. I'm going to stop the recording here.